they're doing to do now. Oops, that's not the do now. Right down there, right in the equation of the tangent line. It's all good, right? You only need a little bit of information to do this, right? All right. So how are you going to, in general, how are you going to get the y1? What are you going to plug into what? Into f of x. You're going to plug the -1 into the function. That gets you your y1. And how do you find the slope of the tangent? F prime of -1. And then we have the x plus 1. So we just got to find those two numbers. I did? Why? Yeah, they gave us this. All right, so let's get our y1, f of -1. You plug -1 into your function, and are we okay? It's -1. Now, we have to get the slope of the tangent, so we're going to have to get the derivative. What is the derivative? Good. And we're going to plug -1 there, and we get -6. So now we just got to put all this together. Have the equation of our tangent. So it's y plus 1, because minus -1, y plus 1 equals -6 times the quantity x plus 1. Now distribute in your head and tell me what this would be in slope-intercept form. Bless you. Y equals, yes, Cameron? -6x minus 7. Do you agree with that? Okay, good. Because we're going to do this later on with the calculator. Before we get to playing around with the calculator today, I wanted to see if there are questions on the homework. Now, I did give you, on the back of today's notes, the answers to all the problems. You can look through them. Let's see if you have any questions on those. Yes, Olivia. 23. I don't think I have that one. You're going to have to read that for me. Olivia, could you just read me the problem? Mm-hmm. Mm-hmm. And it was y equals ax squared plus 2? Okay. At 1, -1. Okay. Okay, so we have to write the equation, the normal line, to this parabola at that point. And of course, the annoying thing here is that we don't even know what A is. But this point is on the parabola. So can we figure out what A is? Yeah. What are we going to put in for y? -1. And for x, we're going to put in 1. Right? If that's a point on this parabola, when you plug in the x and y coordinates to the point, the two sides have to be equal. So we have -1 equals a plus 2. What does a equal? -3. -1 minus 2 is -3. So we know that the parabola really is y equals -3x squared plus 2. That was just a little extra work. Now we want to write the equation of the normal line at that point. First, let's find out the slope of the tangent, and then we can get the slope of the normal. So to get, what are we going to have to do to get the slope of the tangent? Derivative. And what would the derivative be? -6x. So what would the slope of the tangent be at x equals 1? I'm sorry, 1. So we're going to take y prime at 1. That would be negative 6 times 1 equals negative 6. So what would then be the slope of the normal line? Positive 1/6. Okay. We've got the slope of our normal line is positive 1/6. It's got to go through this point. Can we write the equation of the line? Let's do it. Oh, can I get rid of that? Okay, so y minus the y coordinate, so it's y plus 1 equals 1/6 times x minus the x coordinate, x minus 1. Bam. Good. Other questions? Anything else on the homework? Yeah. I mean, there were a few when you had to, the power was greater than the root. We discussed that. Oh yeah, on my answer key, in case it's bothering you, when I simplify this, it should be -1. I think I just wrote 1. When you subtract in the opposite order, you have opposites. So that always equals just -1. But the important thing is when you take the derivative of -1, you get 0. That was number 17. So on the key, I think I wrote, it didn't matter for the answer, but in case it was bugging me. Other questions? No? You want to just play with the calculator, right? Let's play with the calculator. Woo! Everyone have a calculator today? No? Can you just reach in this straw? Here, see, I think one of those work. Let me see. Yeah, come get it, because that's, yeah, that one. That's fine. Anyone else need a calculator? Or you just look on with somebody? Okay. Today we're going to just do a few things. Mostly it's going to be with the calculator. This first one is just a typical AP question where instead of giving you the actual function, they just give you some points. Here they have the x coordinates of the points in the top row and the y coordinates of the points in the second row. So basically they've given you 5 points. And so they don't, and they're asking you to approximate the derivative at 2 when x is 2. And they gave you these 5 points. I'm just pretending to plot them. I'm not really plotting them. But, it's like 1.96, 6.16. That's 1 point. And the next point. Now, the derivative at 2 is the slope of the tangent line at 2. That is the slope at a single point. We're not going to be able to get it exactly. We're going to estimate it. What formula should we use to approximate the slope of the tangent? We can't get the derivative. We don't know what this function is. Difference quotient, right? The slope formula. Difference of y's over difference of the x's. Now, the thing is, we're trying to approximate the slope of the tangent at this middle point here, 2. If I use the slope formula, should I use the first 2 points? Should I find the slope between these two? How about the first and last one? No. You want to get as close as you can to that point. So there are basically 3 acceptable choices here, and we can choose any one you want. You can either use the point before and the point after. Right? You could use the 1.98 and the 2.02. Or you could use the 2 and the one after, or the 2 and the one before. So if you choose any of those, that'll be a good approximation. So the one before, the one after, the one before and the one at 2, and the one at 2, and the one after. So what do you want to use together? One before, one after? Does that sound good to everyone? Okay. So we're going to approximate f prime of 2. So we're going to approximate it. Now in slope formula, the numerator has to be the difference in y's. And we're using the one before and the one after. What should I write for the numerator? 6.30 minus 6.19. Good. And what about the denominator? 2.02 minus 1.98. Okay. Remember, we don't need calculators for this. What is 6.30 minus 6.19? 0.11. What's 2.02 minus 1.98? 0.04. I don't like decimals in my fractions, so multiply top and bottom by 100, and you get 11/4. That's it. That's how you approximate the derivative if all you're given is a table of values. You just use the slope formula. Just pick 2 points either there or nearby. Makes sense, right? Now we're going to have fun with the calculator. I promised you, it's happening. You've seen it before, but remember using this math 8? We're going to do this together, though. Remember we had to get the slope of the tangent, and we just got the derivative, and we plugged in -1? Well, your calculator will not tell you that the derivative is 6x, but it will tell you what the derivative is at a particular value. And you do that with math 8, numeric derivative. You're going to put in the function. That's going to be your 3x squared minus 4, comma x, comma -1. So let me just get with you here. So I want to get out of this, y equals. Okay, so we want the derivative of 3x squared minus 4 when x is -1. So we hit math 8, the function 3x squared minus 4. The comma is over the 7, comma x. You have to tell the calculator to use x as a variable, not to use the number stored in x. And then comma -1. Enter. You should have -6 down. You guys get -6? Okay, which is what we got when we got the slope of the tangent. We just figured out the derivative and plugged in -1 ourselves. So the calculator will not tell you the derivative is 6x, but it will tell you what it is at a particular x value. So that's just -6. Now, another way the calculator will tell you the derivative at a particular value is if you graph the function first. This is kind of cool. So let's put this parabola into y1. So y1 is going to be 3x squared minus 4. You weren't in function mode? Ridiculous. It's ridiculous. 3x squared minus 4. Now, if you're going to use the calc menu, you want to see the graph. So a nice window for this would be a zoom 4, a zoom decimal. You should see it like this. You see that parabola there? Now, whenever you want to know about a graph that you have, you can go to the calc menu, which is above the trace. So you're going to press second trace when you want to work with a graph that's on your screen. So second trace. And we're going to go to option 6, which is the derivative. This is just another way to get the calculator to tell you the derivative somewhere. Now, it brings you back to the graph, and when it does, just type in -1. -1, enter. What's nice about this, it still tells you the derivative is -6, but you actually see the parabola. You can see that the slope of the tangent would be -6 right there. That's it. You get that to work, kids? So you don't have to have the graph if you use the math, the nderiv, the math 8. But if you have a graph and you want to get the derivative, use the calc menu option 6. Now it gets even better. Wait till you see. This is like we're going to skip 4 for a second because I kind of did that. We're going to go back to it. I want to get to, we'll go back to, yeah, lies we'll go back to. Now, not only will your calculator, if you have the graph, show you the point and get you the derivative there, it'll actually draw the tangent line. Remember in the do now, you guys wrote the equation, the tangent line? Remember that? Okay, calculator will do that. Don't get used to it, though. I mean, do it yourself anyway. So make sure that you have the graph on your screen. So go back to your screen. Does everybody have the parabola and the graph there? Okay. To draw the tangent line, you're going to go to the draw menu, which is second program. Second program. And tangent, this is our draw menu, is option 5. So if you press 5, now I'm at -1 already, so I'm going to just hit enter. But if you were somewhere else, you would just type the x value where you wanted it to draw the tangent line, and then you'd hit enter. But I'm already here, so I'm just going to hit enter. And watch this. What? Now, not only did it draw the tangent line to the graph at x equals -1, do you see this? Remember we did that in the beginning of class? Isn't that awesome? That's what we got, right? Yeah, so don't even try to do the math yourselves. That's what I'm trying to say. Just have, press buttons. No, wrong, right? Because, of course, this is a good time to go back to that 4 now. We did talk about it, so it's going to be a little old, but it's a good thing to review. I skipped over this one. Just don't get too dependent on these calculators. They're not that smart, all right? Remember when we talked about, sometimes the derivative won't exist because it is a limit, and limits don't exist when the left and right-hand sides aren't the same. And we actually talked about this one example, y equals the absolute value of x. Now, if you had to figure out what the derivative was without, calculator, you would first have to write the absolute value of x as a piecewise function. When x is greater than or equal to 0, what is this part of the graph? Y equals, well, its slope is 1, but what is this equation over here? That's just y equals x, right? But over here, this is y equals -x. So when x, I'll put b equals there, doesn't matter. Okay. So if I were to ask you for the slope, the derivative of the first branch, what would that be? What's the derivative of x? 1. Now don't include the 0 because then you're assuming that it exists there. So when x is greater than 0, the slope is going to be 1. How about, what is the derivative of the second branch? -1. So when x is a number less than 0, the slope is always -1. But what about the derivative at 0? F prime of 0. No matter how close you get from one side, that slope is always 1. From the other, the slope is always -1. Does f prime of 0 exist? Does not exist. Now, we did this the other day, so we know it doesn't exist. Okay, it's a limit to one-sided limits. But remember how the calculator, it's going to say 0 because it uses the symmetric difference quotient. It goes the same amount on either side and finds the slope. And so what number is it going to return to you when you ask it? 0. So even though the derivative doesn't exist, the calculator is going to say it does exist and that it equals 0 because it's not using limits, right? It's using the old slope formula, the symmetric difference quotient. I got it written over here. So it finds the slope of the secant line, not the slope of the tangent line. That's why it's lying to you. And it laughs every time you jot it down. Laughing. Do you remember the other cases when the derivative didn't exist and the calculator gave us a false answer? Cusps, right? And there was another one, like in the cube root of x. What happened there at 0? The vertical tangent. It's going to just give you some big number, right? So cusp corners and vertical tangents, that's when the calculator is going to give you a wrong answer. Usually it's very, very good. Usually the method uses it is excellent. Now, there's one other thing you can use the calculator for, and that's if, like I told you, it won't tell you the derivative is 6x. But here's a way you can kind of check if your derivative is right, other than go to Google or whatever you kids do. Suppose you see f of x equals 3x squared minus 4, and you're thinking maybe the derivative is 6x, but I'm not sure. Here's a way you can kind of use your calculator to check. So you think it's 6x, so you're going to put that in y1. I'm going to go to my calculator. So you put your guess for the derivative in y1, 6x. And what you do is you ask the calculator to graph the derivative in y2. So in y2, you're in your graphing screen, hit math 8, the function, which was 3x squared minus 4, 3 squared minus 4, comma x, and here's the key part. When you're graphing the derivative, you do another comma x instead of comma some number. And what it'll do is it'll calculate the derivative at all these values of x and make a graph out of it. And if your graph and the calculator's graph of the derivative overlap, you've got the right derivative. Oh, and I can change mine. I'm going to make mine a different kind of a, maybe. Yeah, I just want you to be able to see it. All right, so now I'm going to go to the graph. I guess I'm a good window right now. So that's what I thought, 6x. And here comes the graph. You know, I use that little thing. And they overlap. So that's a good way to check that I guessed the derivative correctly. Kids aren't going to really do that. I don't really think they will, but they might. Something to do. All right, so you can use that to check. You can graph the derivative. It just won't give you the equation for what you're graphing. So there are two basic ways you can use the, or it says, can you use the TI-84 to find the derivative? Not the general rule, but you can find the derivative, okay, but at a particular value. So yeah, you can use the TI-84, 83, whatever you have to, I'm not going to write it down again. So either you can use the nderiv, and you put it in like that on your home screen, or you graph a function, then go to your calc menu and enter value. It'll only give you the derivative at a particular x value. It will not tell you the rule for the derivative, just the value. You want to be familiar. Most people use nderiv because you don't have to graph it first. And remember that the calculator will give you a wrong answer usually if you're asking for the derivative at a point where it's non-differentiable, where you have a corner, cusp, or vertical tangent. So just be aware of that. It always says 100, yeah. No. You see 100, you're suspicious. It could be 100, though. No, so your homework is just the one side of the sheet. Does everybody see that there? Again? Let me see this. See if I have it here. Do I have it attached? No. nderiv homework. So it's a fun little sheet. So even though you don't know how to find the derivative of the ln of x, you're going to ask the calculator what the derivative of ln of x is at 4. So you're going to use like your, you can use either one. All right, so you're going to be finding the derivatives just using your calculator. Fun. I'll let you see what you can do with that. All right, I'm going to stop this. See you, kids. Remember, watch tomorrow's if you're not here.